Now moving forward, let's take up the next one. An engineer is required to visit a factory for exactly 4 days during the first 15 days of every month, and it is mandatory that no 2 visits take place on consecutive days. Then the number of all possible ways in which such visits to the factory can be made by the engineer during 1 to 15 June 2021. Simple question. How to start it? Let's say 1, 2, 3, 4. These are the days when he is visiting. X1 days are previous to the first visit. That means he visits first time after X1 days. Then X2 days, then X3 days, then X4 days, and X5 are still remaining. Clearly, X1 and X5 greater than equal to 0. X2, X3, X4 greater than equal to 1. Now, we can change X2, X3, X4 as Y2 is X2 minus 1, so greater than equal to 0. Similarly, Y3, Y4 greater than equal to 0 by considering X3 minus 1 and X4 minus 1. When you replace back, you are getting equation X1 plus X2, X2 meaning Y2 plus 1 plus Y3 plus 1 plus Y4 plus 1 plus X5 is equal to 11 because there were 15 days and on 4 days he is visiting. Correct? Now, what we are getting here? We are getting as X1 plus Y2 plus Y3 plus Y4 plus X5 is equal to 8. So what is the result here? Non-negative integral solutions of this equation. Therefore, required ways equals 8 plus 5 minus 1c 5 minus 1, that is 12c4 or just 495. So the correct answer for this question is 495. Now the format is of the numerical value type. So let's say this is 495.00. So I'm sure this question is clear how we are getting the answer. Let's take up the next one. In a hotel, 4 rooms are available. 6 persons are to be accommodated in these 4 rooms in such a way that each of these rooms contains at least 1 person and at most 2 persons. So 6 to be divided into 4 rooms. So what is the way here required? This is again simple one, and we can see that we can plan like 1, 1, 2, 2, 4 groups. Further we have to arrange also. So let's do one thing. First break it into groups, then arrange. So it's simple. Required ways equals 6 factorial divided by 2 factorial, 2 factorial, 1 factorial, 1 factorial. That's the division. Since 2 are equal, 2 are equal. So into 2 factorial whole square. So that's the required number of ways. Now we can see it is 720 upon 16. Now this is the group division. What is the requirement? Arrangement. So what else required? Multiply by 4 factorial. So that will give you the required result as 1080. So how many ways required finally? 1080. So let's write down the correct answer for this question. That is 1080.00. I'm sure this question is also clear. Time to take up the next one, that is question number 15. 2 fair dice, each with faces numbered 1 to 6, are rolled together and the sum of the numbers on the faces is observed. Obviously, sum of the numbers can be 2 to 12. This process is repeated till the sum is either a prime number or a perfect square. Suppose the sum turns out to be a perfect square. It is given, it's coming out as a perfect square before it turns out to be a prime number. If P is the probability that this perfect square is an odd number, then value of 14P is. Let's understand the statistics. Sum possibility, it is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What I have done, this is the case for prime numbers. This is the case for perfect squares. And this is the remaining one. Correct? So these are the three cases possible. So when you talk about the sum, let's see how it is being configured. Sum 2 is obtained as 1, 1, sum 3 is obtained as 1, 2, 2, 1, and so on. Now what the question is saying, it is given that let's consider two events. One is say E. I'm saying E meaning it is a perfect square. It's a perfect square. Correct? If you want, you can also say this is E1, not going to make any difference. You can say E and F or E1, E2. Let's say another event E2, which is perfect square is odd. Correct? Now, we have taken two events. What is required? So, probability that perfect square is an odd number. Correct? It is given that the sum turns out to be a perfect square before it is coming as the prime number. I'm saying this perfect square is the odd number. Alright, so the requirement, probability this perfect square is an odd number given that it has turned out to be a perfect square is equal to probability E1 intersection E2 divided by probability of E1. Now E1 intersection E2, E1 meaning it's a perfect square, E2 meaning perfect square is odd, so obviously intersection is odd itself. So this is the probability of getting odd number. Odd, how many cases are there? We need to find this term for perfect square, then for odd number. Perfect square 9, that means it is starting from 3, 6 going till 6, 3. So there are total 4 possible cases. This is clear? Now for 4, how many cases are there? For 4 starting from 1, 3 going till 3, 1, there are 3 cases. Next, odd numbers. We need to figure out every term. Total for perfect square it is 7. Correct? So probability of getting a perfect square, probability of getting a perfect square in one throw, this is 7 by 36. It's in one throw because the question is saying it is repeated till it is stopped. Probability of getting a prime number, we need to count how many cases are there. 1 plus 2 because 1, 2, 2, 1. 1 plus 2. For 5 starting from 1, 4. So there are 4. There are 6 ways. There are 2 ways. So total we can see this is 10 plus 5, that is 15. This is 15 by 36. Correct? Now let's move on to the question part. Probability of E2 by E1, which we simply concluded this will be the probability of E2. Correct? Let's say the dice is rolled. When 2 dice are rolled, you are getting a perfect square as odd number. So game will be stopped. Perfect square is odd number. So let's write down probability of odd perfect square in one throw. This is simply 4 by 36. So this is 4 by 36 plus. Now suppose it is rolled but it is not a perfect square. Question is saying that we are getting a perfect square and we have to stop at that case. Correct? Meaning in first throw it's neither perfect square nor a prime number. It's the additional number. Since we have 15 cases as prime and 7 cases as perfect square, so 22, how many remaining? 14. So yes, now it's quite simple. So it's 14 by 36 in the first throw, and in the second throw you are getting the correct requirement, meaning 4 by 36. And so on. This process goes on, so it is infinite series. Divided by, what is there? Probability of E1. And what is even case? Even is that it is a perfect square. So this is 7 by 36 plus 7 by 36 multiplied by 14 by 36 and so on. So you can see that everything will be cancelled and just you are left with 4 by 7. This is the required probability given to me as P. Now what the question is talking about, let's check out. Question is saying then find the value of 14p. So the value of 14p, just multiply this term with 14, that is the obtained probability, which is 4 by 7. Multiply by 14, what's the answer? 8. So let's write down the correct answer for this question is 8 or simply 8.00. So the answer for this question is 8.00. Let's consider the next one.